look. You should have gotten 2 pages. This one that says 1024 quadratic regression, and then this one that says 1025 quadratic regression. Okay, so like I said, essentially on the calendar originally it said we were going to do day 1 some practice, day 2 some practice, but I'm going to jumble that a little. We're just going to go ahead and knock out day 1 and 2 notes. We'll do notes today. If we end up with a little time to start the assignment, great. I don't know that we will, but then that'll give us all of tomorrow to do the assignment. And instead of being 2 shorter assignments, it'll just be 1 practice assignment for regression. Okay, so the word regression should sound familiar. Okay, we did linear regression back in it's either unit 1 or unit 2. I can't remember off the top of my head, but we have done the regression process for linear functions. Okay, it is very similar for quadratic. It's just what you're typing in to Desmos to get the regression model is different. So this right here is what we're going to type in for quadratic regression. Okay, so we add a table, fill in the data for the table, okay, and then we go to the next box and we type this in. Okay, when we were doing this for linear functions, the first 4 steps was exactly the same. We hit the plus, add a table, enter the data, go to the next box to type an equation. It's just what you type that's different. Okay, for linear functions, when we were doing regression, once we had our data entered in the table, we did that y1 tilde, that little squiggle line there, mx1 plus b. Do y'all remember that? Does that sound familiar? Okay, so it's the only thing that's different is instead of mx plus b, which is linear, we're using ax squared plus bx plus c. Okay, but we still have to remember when we type in our x that we put that 1. We have to use y1 and x1. And remember, we have to use the tilde sign there, that little squiggle, instead of an equal sign when we're plugging that in Desmos. Then it's going to generate the statistics or the data that we need, the parameters. It's going to tell us what A, B, and C are based on the data in the table. Okay, so we're going to go through this process, okay, with this first example. Okay, and then we identify A, B, and C, and we round it based on what the question tells us to round to and write our regression equation in this standard form, quadratic trinomial. So far, so good? Okay, so you can have Desmos open so you can follow along with us. This first one says that a rocket is shot off from a launcher. The accompanying table represents the height of the rocket at given times, where x is time in seconds and y is the height in feet. Write a quadratic regression equation for this set of data, rounding all coefficients to the nearest tenth. Using this equation, find the height to the nearest foot at the time of 1 second. All right, so 2 things. We need the regression equation, and then we're going to use it to make a prediction. So the first thing I'm going to do is open up Desmos, and I'm going to follow those steps at the top of your notes. I'm going to hit the plus sign, add item, and then I'm going to choose table. Okay, so I add a table. Now I'm going to enter the data from this table. So my x's are 0.3, 0.8, 1.4, 1.7, and 2.3. And then my y values are 41, 103, 167, 195, and 242. Okay, so I've got my data entered. So now I go to the next line, line 2, and I'm going to type in my quadratic regression model. So y1, oops, not that one, a squiggle, a, and then x1 squared, make sure you get out of the exponent, plus bx1 plus c. When I finish typing that in, all of these parameters should pop up. Okay, and remember when we were doing this with linear regression, we looked at that r squared value and we talked about how it's going to be a number, it's going to be between 0 and 1. And the closer it is to 1, the better the fit, the more accurate the model represents the data. So this r squared is exactly 1. So that means this is a perfect fit. Okay, this is this model that was generated here. You can see the graph, the parabola popped up here. Okay, and you can zoom out, you can see the points from the table are there. Okay, and then this is the quadratic, the parabola that goes through those points. So now we want to write the equation for this parabola. Okay, and they give us the A, B, and C to do that. Let's split the window here. So I'm going to label A, B, and C that I got from Desmos. I got negative 15.6838. Got 141.298 and 0.00903516. Yes. What's up? All right, so I've got that information. So now I want to write the regression model. Got to pay attention to what they want us to round to. Okay, so write the quadratic regression equation, rounding all coefficients to the nearest tenth. So A, B, and C need to be rounded to the nearest tenth. So I'm going to write my equation. A would be negative 15 point what? What is that rounded to the nearest tenth? 0.7, very good. Okay, that 8 would round that 6 up. Okay, so negative 15.7 x squared, then b is positive, so plus 141 point what? I'm rounding to the 10th. Good. That 9 would round that 2 up to a 3. Okay, and then you have x. And then what about my c? I'm rounding to the nearest 10th. What is c? It would just be 0, right? 0.00. Okay, so my c rounded to the nearest tenth is just 0.0. Do I actually have to write a 0.0? No. So all of these are rounded to the 10th. Okay, but I don't have to have 0.0 or 0 at all. So I'm just going to write this like this. So that is my regression equation. So now they want me to use that to make a prediction. Okay, so what I'm going to do is I'm going to go back to Desmos and I'm going to get rid of everything that's there. Okay, because I want to use this model that I came up with. Okay, with the rounded values that it told me to use. So negative 15.7 x squared plus 141.3x. And you can type it like that. You can put y equals at the beginning. Doesn't matter. Okay, and you get your regression model. You get this parabola over here. Now we want to use this model, this graph, or you can come up with a table here. Remember, if you have an equation typed in, you can hit the gear, this edit button, and create a table with those rounded values for that equation. Okay, so now we want to use this information to make the prediction. It says to predict, use this equation to find the height to the nearest foot at the time of 1 second. Okay, so we are looking for the height, which that's the y value, right? X was time, y was height, to the nearest foot at time of 1 second. So when X is 1, what is Y is what this is asking. Oops. When X is 1, what is Y? That's the question. Okay. So you have a couple of ways to answer this. You can just plug in a 1 for X. Like that. So plug in a 1 for X and calculate. Okay. And I can type that in Desmos and calculate it. Or if I have the table that I created here for this equation, I can look where X is 1 right here. When X is 1, Y is 125.6. Now, what did it say to round that to? It said find the height to the nearest foot. Okay, so this is measured in feet. They don't want 0.6. They want the nearest whole number. So what is this going to round to? 126 feet. Another way you could look at this, anytime they give you an X value and they want the Y value, if you like to use your graph, okay, so we've got this parabola drawn, okay, you can type in the X value that they're giving you to find where it intersects. They're saying when X is 1, and it'll draw a line where X is 1, and you're looking for that intersection. Okay, and I can see that intersection right there. When X is 1, that's Y. So you can use the graph, you can use the table, you could plug it into the equation and calculate. So you've got a few options. Now, if they gave you Y and asked for X, you could do the same thing. If they said, how many seconds before the rocket is at, let's say, 100 feet, you could say where Y is 100, because that's the height, okay, and it'll graph a line where Y is 100, and you're looking for that intersection. It would be at about 0.8 seconds. It would be at 100 feet. So you have to be able to use the table, use the graph, use the equation. What we came up with for the regression model, you use that to answer questions about the scenario. Do you follow? Okay, let's try this second example here. So I'm going to clear out everything from my calculator because I've got a new problem. Okay, this one is talking about a company selling widgets at various prices to see how much of a profit they can make. So we can see here, the following table shows the selling price, X, and the total profit, Y. So when they sell the item for $13.25, their total profits are $553. Okay, so the selling price and the profit. write a quadratic regression equation for this set of data, rounding all coefficients to the nearest hundredth. Okay, so we're going to do the same thing we did on the last one. Okay, we're going to write a quadratic regression equation, but we are rounding coefficients to the nearest hundredth instead of tenth this time. Okay, but I'm still going to start by creating a table. So add table. I'm going to put in the data. 1325, 275, 25, 29, 34. Is 553, 666, 856, 778, and 595. Okay, now I'm going to type in my quadratic regression model. So y1 tilde ax1 squared plus bx1 plus c. And now it's going to give me these parameters. It's going to tell me what a, b, and c are. So I'm going to jot these down. Not what I meant to do. So a is negative 2.8377. B is 134.215. And C is negative 736.215. All right, now they want us to round those to the nearest hundredth to write our equation. Okay, again, if you need to jot this down, we're writing it in ax squared plus bx plus c form. So the a would round to negative 2.80, okay, because that is the hundredths. The 3 does not round the 0 up. Okay, and then I've got x squared, and then b is 134.22, because that 5 rounds that 1 up, x, and then c is negative 736 point also 22, because that 5 rounds that 1 up. Okay, so these are my rounded values, rounded to the hundredths, like we were told. So far, so good? Okay, and there's nothing to simplify or do. That is my regression equation. So now I'm going to come back to Delta Math. I'm going to clear everything out, and I'm going to type that equation in. Negative 2.80 x squared plus 134.22x minus 736.22. Okay, so I've got the graph over here. Okay, you can zoom out if you need to try and see the whole thing. Okay, the vertex is way up there. Okay, so I've got my data. I can, oh no, I did not mean to delete that. Undo. Oh, good. Okay, it came back. Okay, I can click in here and I can have it create a table. Right, and I've got my equation, I've got my table, and I've got my graph. Now I'm going to answer the question that it's asking. It says use this equation to find the profit, okay, to the nearest dollar for a selling price of $20.75. Okay, so that is, if the selling price is $20.75, we want to figure out the profit to the nearest dollar. Okay, so again, the profit is your y. So they're saying, what is y when x is 20.75? That's the question. Okay, so multiple ways we could do that. It says to use the equation. So you could plug in 20.75 for x. It'd have to go in both spots. X is twice in the equation. Or you could come to the table and you could type in 20.75 as the x and see what the y comes out as. I need to make this bigger so we can see it. Okay, so when x is 20.75, the y is 843.27. Now, where did that come from? It came from plugging in 20.75 for the x in the equation. And to plug it in both spots. Okay, so use the equation, table, or the graph in Desmos. Okay, so you can type it in the equation like this. That's not what we did. We typed it in the table, okay? Or you could have used the graph as well. You could type in x equals 20.75 and go find the point of intersection, and it would come out the same. Now, it did ask us to round this to the nearest dollar, so what would that round to? Means I don't want the change. I don't want the 27 cents. So is this going to round up or stay 843? Yeah, 27 cents wouldn't round it up to the next dollar. Okay, 0.2 does not round that up. So it's going to stay 843. Y'all feeling okay about this regression process? So these first two examples were really just practicing putting the data in Desmos to write the regression model, the regression equation, okay, and then using it to make a prediction. Given a certain x value, what would be the y value? Okay, and practicing your rounding. Make sure you know your place value. So now we're going to go ahead and take a look at that second page. Actually, I'm going to stop this video real quick and then start a new one for this.